absolute space, by its very nature and regardless of anything else, remains always immobile and immutable. Absolute, true, and mathematical time of itself and from its own nature flows equably without regard to anything external, and by another name is called duration.
What kind of a universe does this Newtonian notion of space and time imply? And what are the implications of such a conception for society? Isaac Newton was never really a scientist in the true sense. He was created and promoted by circles around England's Royal Society at the turn of the 18th century in order to destroy science. Actively opposed to Newton was humanist, scientist, and politician Gottfried Wilhelm Leibniz, the key intellectual author of our own U.S. Constitution. Leibniz was exerting influence across Europe and Asia, organizing governments from Peter the Great's Russia to Austria-Hungary to the House of Hanover in an alliance to break up the political control that Imperial Venice, the British Empire's predecessor, had over England and Europe, and to free the world from Newton's assault on science. One of Leibniz's key missions was to destroy the developing influence that Isaac Newton had over science, and to make sure that Newton's faulty conceptions of space and time were not adopted by the society of that day. Leibniz, as many after him, knew that were science to fall into the grasp of Newton's philosophical conceptions, society would find itself in peril.
I have many demonstrations to confute the fancy of those who take space to be of substance, or at least an absolute being. But I shall only use at present one demonstration, which the author here gives me occasion to insist upon. I say, then, that if space was an absolute being, something would happen for which it would be impossible that there should be a sufficient reason, which is against my axiom. And I prove it thus. Suppose space is something absolutely uniform, and without the things placed in it, one point of space absolutely does not differ in any respect whatsoever from another point of space. Now from this it follows, supposing space to be something in itself, besides the order of bodies among themselves, that it is impossible there should be a reason why God, preserving the same situations of bodies among themselves, should have placed them in space after one certain particular manner, and not otherwise, why everything was not placed the quite contrary way, for instance, by changing east into west. But if space is nothing else but this order or relation, and is nothing at all without bodies but the possibility of placing them, then those two states, the one such as it is now, the other supposed to be the quite contrary way, would not at all differ from one another. Their difference, therefore, is only to be found in our chimerical supposition of the reality of space in itself. But in truth, the one would exactly be the same thing as the other, they being absolutely indiscernible, and consequently there is no room to inquire after a reason for the preference of the one to the other. The case is the same with respect to time. Supposing anyone should ask why God did not create everything a year sooner, and the same person should infer from this that God has done something concerning which it is not possible that there should be a reason why he did it so and not otherwise, the answer is that his inference would be right if time was anything distinct from things existing in time. For it would be impossible that there should be any reason why things should be applied to such particular instance rather than to others, their succession continuing the same. But then the same argument proves that instants, considered without the things, are nothing at all, and that they consist only in the successive order of things. This order remaining the same, one of the two states, namely that of a supposed anticipation, would not at all differ, nor could be discerned from the other, which now is. But then the same argument proves that instants, considered without the things, are nothing at all, and that they consist only in the successive order of things. This order remaining the same, one of the two states, namely that of a supposed anticipation, would not at all differ, nor could be discerned from the other, which now is.
For Leibniz, Newton's relegation of man to the role of a mere counter and measurer of material effects, while lacking the power to act on the universe for the good, left man as a slave, without the power to control his own future. Newton's method asks questions about the physical universe, for example, how gravity works, behind numerological magic, which Leibniz properly compared to a medieval occult power. For Leibniz, the idea of space and time as independent, fixed, and absolute never existed. Rather, it was ideas and principles which could be known and discovered by the mind of man, which created the curvature of a single space-time. Unfortunately, following Leibniz's death, his work was attacked viciously by the British Empire, and Newton's mystical hoax of an entropic universe and an absolute space and time became the new scientific doctrine. But a number of unavoidable paradoxes, including the principle that light took a least action pathway through a given medium, and the experiments which proved that the rate of propagation of light was constant in all reference frames, would soon call into question, for the entire scientific community, Newton's conception of space and time. The man to do it was Albert Einstein.
Think of this. Imagine you have an observer standing on the embankment of a train station, watching a ray of light moving from point A to point B. Now this ray of light is on a train which is moving past him. Now you have a second observer who is on that train watching the same ray of light. They both have stopwatches. And when the light begins to move, they begin their stopwatches. When the light reaches point B, they stop their stopwatches. Will the movement of the train have an effect on the ray of light? The observer sees the light move in a diagonal line C, whilst the passenger sees it move in a straight line directly in front of him, D, meaning that for the observer the light has traveled a longer distance. According to Newton, absolute space and absolute time are essentially fixed, and everything else must be measured accordingly. Therefore, to Newton, the velocity of the train must be added to the velocity of the light, meaning that the light has to travel faster over a longer distance, yet the time for the man on the embankment and the man on the train is essentially the same. However, though these times may appear to be the same, what is actually happening? Absolute space and time do not exist, and only principles, such as the speed of light itself, remain constant. If the speed of light is unaffected by the velocity of the moving train car, that is, if it remains at 300,000 kilometers per second despite the motion of the car, then wouldn't the observer have to have had measured a different time from that of the passenger? Upon comparison, it is seen that the time of the event for the passenger on the train is shorter than that of the person on the embankment. How is it that, given the same event observed, two different times are measured? Space and time are not separate. They are essentially of a single indivisible unit. You cannot have a space or reference frame without a particular time, and you cannot have a time without a particular space.
Einstein declared that since not all clocks could be definitively synchronized, then time was not after all absolute, as Newton had believed, but rather relative to the frame of reference of the clock by which it was measured. Similarly, since there existed no definitive empirical method to detect whether an object's motion through space was absolute, Einstein declared that all spatial relations were also relative to a given reference frame chosen. Principles, such as the least action principle of light and the constancy of its speed of propagation, remain valid throughout the universe. It is only principles which make up reality, and those principles, like the example of gravitation in our solar system, actually create the space-time we experience. Therefore, space-time, rather than being the box in which phenomena and events occur, become merely the shadows cast by the action of a principle or phenomena.